Hello, welcome to another episode of FreeCodeSession. My name is Jason Bach, and I'm going to talk about a couple things off the bat first. One is the name change. I realized a while ago that limiting this to one day a week on Friday is just not cutting it. In fact, this episode is being recorded on Thanksgiving while we're just down at my house, not going to visit family or anything like that. So I have a very lazy day, and my kids are playing video games. So I figured I'm going to have the things I'm going to be doing today have been on my mind for a little bit, and so I wanted to spend some time and address them. And I realized, just because this isn't Thanksgiving, I don't think this is going to go out until mid to end January. So I'm switching it up from this point on, in that I'm always going to do one episode a week. So it's got to be on by Friday. The other thing is that I'm going to make sure, get that out of there because otherwise it's going to be distracting. It was recording, right? I always got to make sure of that. Yep, okay. So one session a week by Friday, but if I'm stockpiling up too much, it might, be better to release a couple during the week. I will say I'm going to limit myself to no more than 7. I don't know if I'd ever get up to that much, but I don't want to just push out episode upon episode just for the sake of doing it. So I'm always going to do at least once a week, but if I start bashing out a bunch of them, then I want to just, do more if I can. So it's no longer going to be Friday. So FreeCodeSession is the name that I have to keep in my head now from this point on. So that's the change there. So what am I going to talk about today? I am going to talk about file. Do I have it here? Okay. Oops. We're going to talk about rocks again. So I think I mentioned in the last episode that, come on. I think I mentioned in the last episode that this is something I've been thinking about for a while, which is how can I make this faster? Can I do anything here that could possibly make this even better? Oh, that's another thought I had. Hold on. I forgot about something that I wanted to add in my notes here. And maybe get to that later. But I wanted to see if there is anything I can do within rocks to make it faster, make it take less memory. And I'm not sure if there is. I have no idea where the hot spots are. So I've been thinking about how can I address this? How can I make this so that I have some way to potentially find out where things are, and then also as I do releases to have a strategy around not regressing if at all possible. So what I'm going to do for now is create 2 apps. And before I do anything, we're going to create a branch. And this is profile mock generation. So it's 91. I'm going to do 91 underscore profile mock generation. Yep. And I'm going to create a profiling app. That app is just going to drive rocks doing something, and then I'm going to run a profiler on it to see what can be done to improve the hotspots. Then I'm also going to create a performance console app that will be benchmark.net, and that will just have a bunch of tests in there to see does it actually do the things I want it to do. And it's be a little bit of a change for me in terms of how I use benchmark.net, because typically I use that tool as here's a class and here's some methods with alternative approaches to doing things. Which one is the fastest? And that's not what I want to do with performance testing. I want to have a class that just has a bunch of tests, run the tests, and see how they actually perform. And one thing I found out, which is, I actually found this out on the Gitter channel, and this was really interesting, is that you can have benchmark.net run two different versions of an assembly if you have them as a NuGet package, which is awesome, because that was the thing, is how do I make sure I regress? I don't want to run it once and then change a version and run it again. As long as you have a NuGet server, and you can use a local one too, you can specify a way to do that, and benchmark.net will, as long as there's binary compatibility, which makes sense. You can't just, if you have a newer version of an assembly or a NuGet package and that breaks the binary compatibility of what you're testing in some way, then that's not going to work. And I get that, that makes sense. But and you can use local NuGet servers either. You don't have to push it up to NuGet, which is also a nice realization. And all this was told to me by a guy I think that is actually, apparently he is the person that does Fake It Easy, which is funny, another mocking framework. And I've always said with Rocks is that the point of it was not to compete in any way. You know, I know MLQ and NSubstitute are two of the biggest ones out there. So I have no interest of actually trying to, upend them in terms of their usage. That's not the point. I've always done always done Rocks as an exploration of what you can do with Roslyn and mocking, and that's been the primary focus. Is just really fun investigation for me. I find it fun. But it was just cool to see somebody else who is on a framework that is competing or doing the same thing, which that's not it at all. But just say, hey, give this a whirl, and these are the things that you can use if you want to test more than one version. I'm like, that's cool. So with that, let's see here. The first thing I want to do is, let's create a new project. And we're going to call this rocks.profiling. And it's just a console app. Okay, cool. Now I'm also going to be doing some arguably yak shaving here in a second. I'm going to update some packages because I know, these things are, select all of them, and just say update. There's also a tool I just found, and I forgot what it's called, but you can use it in GitHub that it will actually find when you're Dependabot. That's what I think it's called. And I haven't included it on many of my projects, and I really should, because what it does is that it will give you notifications. I think it actually does like pull requests automatically or something like that. I'm not sure what it is, but it's really cool because it will tell you, hey, a new version of this package is out there, and you can choose to either update it or not. It's up to you. So yeah, that's kind of interesting. Oh, we don't have jobs anymore? Yep. Okay, that's fine. I'll do that. And then, yes. And of course, because reasons. Okay, so what do I want to do here? I want to be able to just create a mock, but create it in such a way that it doesn't cache it, because I do that for performance reasons. Once you give me a type of or an interface of A, and you ask to make a mock of that again, I don't go through the generation step of it again. I already have a type that is a mock of the type you're asking for. So I keep a cache around. But fortunately, I put in a case where you can override that with the options. This is actually, I think, one of the first times I've used Rocks in quite a while, so I might have to actually go look at my own code to go, what am I doing? So let's make sure that this has references to Rocks, which it should. And this is 2.1, right? Yep, good. Good. Oh, I should, though, make sure that I do all my goodness, which is lang version, blah, 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 blah. Well, I don't need unsafe blocks, at least not yet. I may later, because I know Rocks supports that, and I might have to do that. Profiling. And we'll stick with the same version until I'm okay with it for now. Okay. I'll close. Sure, whatever. Okay. So what I need to do is I'm actually going to go to my own help file because I should actually take the .NET Core support out because it doesn't need that anymore. There's no problem with that. To do the simplest one, let's do the simplest thing that I can do. I am simple. Oh no, I know there's a that. Move type. Okay. And then I just say, just copy all this. And actually though, I don't, in this profiling test, and this is actually a good point, what I want to do is probably have specific classes that instead of just polluting the program file. So we're going to say profile simple mock generation. Be very clear as to what I'm trying to do. Internal CO static. Then we're going to do internal static void profile. So the name of the class will just say what is it that it's trying to do, and then you just call profile. We'll just do it by convention. You know, because I'm trying not to profile this. I'm trying to profile what Rocks does. And then I can easily switch on what I'm trying to profile based on that. That should be good. Okay. So, whoops. Using static. No. What did you? That was stupid. Why did it do that? That was just weird. Okay. So then we need to handle a do it. And I don't really need to capture that. We just want to do this. Okay. But I need to have options in here. Options. Yeah, there we go. So, yeah, it's an, okay. And then we want to set, which one is it? Caching to caching options, generate new version. Okay. And I want to do this for, let's do iterations here. Private set, private const, uint, iterations is equal to, let's just do 1,000 for now, because as I generate a new one, that's always going to generate a new type, and that's a little concerning because the memory pressure is just going to go up and up and up. And so I have to balance this with not creating too many, but doing enough so that a profiling session could actually catch enough here. So we're just going to see how long this takes, and then we'll just keep bumping up iterations until it gets to where we want to be. Release is good. Okay, so then we want to say for var I equals 0, I less than profile simple mock generation iterations I plus plus. And then we need to come back to our program, and say present G profile. Very simple. Pretty simple. Why are you a partial class? Why would you do that? It should just be a public static class. Maybe it got screwed up when I said move the interface, I guess. Maybe. I don't know. Let's see what happens when we run this. Wow. That's good. Well, it's good that it's actually taking this long in a way because then I'm going to get a healthy, profiling on this. So that's good, actually. Okay, 1,000 seems like a reasonable number. I wonder if the blinking there was how long, like, is that a second in a command window? I've never really thought about that, but I was watching the blinker there and kind of like going in my head going, it felt like a second every time it blinked, but I don't, anyway, distracted. All right, so now let's go up to Analyze, and let's do a performance profiler. That is the target. So we got to do one over the other. Performance Wizard, CPU sampling, instrumentation, .NET memory allocation, and resource contention. I use this tool a fair amount, but I still always get a little confused every time I hit it and go, what do I need to do? But it is the right target. I don't need to like hook any exe that's already running or anything like that. I just need to say, make that the startup project and go. So let's see, start. What kind of, so you're going to do CPU bound applications with low overhead. Function call counts and timing. That might be interesting. Memory allocation. Yeah, that might be interesting. We don't really get any concurrency issues, so let's just go with CPU sampling for now. Sure. And we'll let it do its thing. Of course, it's going to take a little bit of time to do this, so is what it is. I may have to change my get ignore to not include any of the profiling stuff that's going to be generated from this, but all right, let's see what it found. I'm guessing what it's going to be as the hotspots are actually the Roslyn things, which wouldn't be surprising. That's doing the bulk of the work, and I don't really know off the top of my head if there's a way to do anything to improve that. I thought I read somewhere that the server version of Roslyn, or there's like a way to make it work differently, where you're going to be doing a lot of code generation and compilation or something like that. I thought there was a version optimized for that, but I could be remembering something I dreamt once, which would be really sad if that's what I'm dreaming about. When I'm sleeping in bed, you're dreaming about compilers and mocking engines. You're a sad individual, but I'm not. I enjoyed this stuff. And I'm not defending myself. I'm not being defensive either. Just I like it. It's fun. Okay. Let's see. And I should say before I actually do some, before I think about a lot of a lot of things that have come in my head in terms of ideas or potential places to go. I actually have some listed over here in my notes. And one of them was, I noticed a type dissector is called a lot. And I might have done a profiling session on this before in a different episode. Maybe, maybe not. But that type dissector is called a lot. And so one idea I had is actually cache type dissector, so that if you're giving it a type that I already had, then make that simple. Don't necessarily don't call it don't make it every time. That's what I'm trying. I was like, why can't I think of that? I was like, just don't call it as much. Cache them like I'm caching the mock types that I make. I get a little leery about that because then that's, you make a cache, then you have another problem. So do you really want to do that? Does that actually make things faster or better? What's interesting is that you can see that the function calls that do the most work, compilation emit, that is not surprising. The parse text, the first one that you see actually from my code is type dissector, get safe name. Okay. So that is not really that surprising at all. If I go back to the summary here, and I say call tree. No, call tree. Because I should put the hotspots up here at the top. Profiling in memory rack, make, get mock type, compile. Yeah, the compiler part is is going to be the brunt of the work. And again, that's not surprising, and there's really not that much I can think to do to make that faster. So oh, there's the get safe name popping up its head, but that's way. I mean, this is compared to what I get from compilation emit. There's no comparison. I mean, this is going to, that is orders of magnitude less than compilation emit. So I got to be really careful here in that. Does what I do actually going to make any difference that's noticeable? And I may not. I may not be able to do anything that's even remotely noticeable. The process streams here, that goes right into core CLR. Can I go? Show modules view, show function details. I thought there was a way to say. Well, let's just go to it. It's process in-memory compiler. In-memory compiler. Process streams. Yeah, that just goes right to assembly load, and there's nothing to do about that. So that's really not much that we can do about. Yeah, there's really, unfortunately, not much that we're going to be able to pull out of this to make it faster. The one thing I could do, though, is there's kind of two profiling sessions here, and this is actually leading to two performance tests I think I'm going to want to create. One is do a test where you're creating a simple mock and you're caching it, because that should be fast. And I should also do a profiling session here where I do cache it. So let's try that. Let's come here, and let's do this with no caching. Oops, somehow I got the insert called on. What? Ah! That. Let's come over here. Oh, you stupid. With caching. There. Get the Explorer out of here. Okay. This way, let's close that. Let's just say program here. Let's say with caching. And I'm just kind of curious in this case, what's going to happen when I say, we just pick CPU anyway, just say start. This should come back much faster. Oh, stop. Yes, I do, because I am a moron with caching. Well, then, don't disable caching, you idiot. Try that again. This is not taking any less time. See, this is much faster this time, which makes sense. And what this might do is give me a little bit more indication as to places in my code that I could possibly optimize, because I think you can see here that compilation emit is only 50% now of all the calls. So that takes that away, and hopefully will show a little bit more in terms of what should show a little bit more in terms of what my code is actually doing. Let's go to call tree. That was just a little weird. I'm like, wait a minute, whoa, 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 whoa. Handle lambda. Really? I've got a handle lambda in there? Okay. Get mock type. Compile. This should eventually get to emit. Yep. Okay. Make tree is going to be parse text, and that's going to be, yeah, a bunch of stuff in there. Can't get around that. What's interesting though is I don't see the type dissector showing up, which actually makes sense, because in this case, okay, I just realized something. Because I'm caching it here, it doesn't help, because I never call any of that other code. So what I wanted to do is run the code that does the generation, but then doesn't actually compile it. And the only way I could see doing that is if I actually went into Rocks itself and hacked it in a sense, so that I disable the emitting code. Which I could do for now. That feels dirty though. It just, no, what are you doing? No. Why do you do stupid things like that? So in other words, come into here and with the construction, there's the in-memory maker, right? That's the in-memory rock make. In-memory maker, yes, okay. God, what am I doing that... Stop it. In-memory maker. Then I should have looked at this. Because it's doing a compile. Oh, God. Why? Why does Visual Studio conflict like that at times? Rocks construction compiler. Compile. And so the thing I could do right now is just toy with this and say, don't call this. In fact, don't call any of this. Which would be really weird, because I don't know what, I can't think of what that would actually break. It'd probably break a lot, because I'm setting the process streams to actually load an assembly, but you're no longer going to have those because you don't actually create the streams of both the DLL and PDB information. So that would actually make things bad. I'm just curious. Let's just try this. I really don't like doing this, but I'm just kind of curious. If I run this, what would happen? Yeah, it doesn't surprise me at all, because all of a sudden I'm not setting things and it's going, hey, you can't do that, stop it. And we don't need exceptions happening. So that's a bad idea. But I have to do something similar to this, in that I got to do something to say, do all the work, except don't compile, don't emit it. And that way I can see which methods are actually doing most of the work. I could do just a simple try catch everything, and then people can laugh at me because I am adamant about don't just swallow exceptions. But again, for what I'm trying to do with profiling, that may be just the simplest thing right now is to see, where things are headed. So let's just try that. It feels dirty. Let's come to the program here, except we'll say with no caching, and profile it. And we'll say here, try. Oh God, I feel so awful doing this. Catch. Of all the people, me, the one that's adamantly against this, I'm the one that's suggesting it. So let's just see what this, no, I didn't switch it. Did I? I did. That was a lot faster than what I thought. I just hope the overhead of catching exceptions is not going to cause too much pain. I know I'm going a little bit over here, but I want to finish on a interesting point. Strategy for the next episode. Okay, so let's just try this. Let's see if I say start, and let's see what it comes up with this time. Now there's some algorithm on YouTube that realized I sang that song and they're going to be mad at me. All right, well, I still see a parsed text in here, which again is not surprising because it's still parsing all the code. I love this little sawtooth thing. Can you see that? That's really interesting. I wonder why. Well, like, what does that mean? What does that mean? I've never actually really clicked on that. I wonder why that little pop-up thing is happening there. But all right, well, this is a little better because this is kind of getting what I'm looking for. So this is almost like the best of two worlds, which is, or whatever worlds, which is going to run through all the code except it doesn't do the generation. And it does it every time. And so this should really show me what Rocks will spend the most time on. And the things with the compiler, I just can't influence. So let's see here. I move this out here. Make code. Get generated methods. Generate. Build. Means delegate conditions. There's the type dissector, which again is about 7%. Okay, fine. Well, that's, I mean, again, in the grand scheme of things, but this is with what Rocks does, and that's all I keep saying the same thing. It's the only thing I can actually do. Maybe I have to improve type dissector, So that's one. And then this ref parameter. And again, there's type dissector. That's taking 793, so it's 4% there. Because it contains delegate conditions. Generate calls build. It must also call this. And both of these end up spending time calling type dissector. Yeah, type dissector now looks like it's getting 3% of all the stuff, which I'm not really sure if that's actually functions doing most individual work. Why does it think core CLR is? Well, that's something. That does make me think that maybe type dissector is the thing to hit. And then we're going to just take a look at this real quick. Oh God, don't, please. When you're on this report, it like takes over Visual Studio and dissect. There we go. It says get safe name, which is always called in the constructor. So I either do this where type dissector doesn't have a public constructor, it only has a private one, and the only way you can get a type dissector is with like a create factory call static on type dissector, and that will look and see, did I create a type dissector for the type you're giving it? And if you have, just return that. Otherwise, do this. You know, we can try that. I can try that. So I'm going to stop here because this is at 36 on my timer here. So I'm going to stop for now because I got to go back and do Thanksgiving things. So if I feel up to it later on, if I haven't gone into a coma with all the food I eat, which really I don't do that. I know the joke is in Thanksgiving you're supposed to eat just a ton of food and then feel like awful and you know, put on sweatpants because your jeans don't fit anymore, whatever you're wearing. I don't do that. But I don't know, maybe, you know, this is going to stick in my head, so maybe later on tonight I'll do another one and actually start looking at how can I, what I want to do is then create the performance project and have tests in there that say like create with no caching, because we've got to make sure caching is off to do that, and then just see what benchmark comes up with and then run it again and we'll see if that actually makes a difference or not. So that's all I'm going to do for right now. Thanks for watching. Leave your comments and questions down below. See you in the next episode.